Hello, dear students. Today we are going to see errors in measurement. We are approaching towards the fag end of this chapter. So, let us see what do we actually mean by the errors in measurement. Before that, how come the error is? So, now when we do measure any physical quantity, every measurement is limited to the reliability of measuring instrument, and also it depends upon the skill of making measurement. What do we mean by it? Does it mean that when we measure a physical quantity, then the measurement has error? Definitely, that is what we are trying to drive the point in. What it says is, whoever be the person is making a measurement, the measurement depends upon the reliability of the measuring instrument, and every instrument has got its own least count. Less than that value we cannot measure. That is one of the limitation of the measuring instrument. Next, it depends upon the skill of the person who makes measurement. The person who is more skilled can measure the measurement of any physical quantity close to its true value, but not exactly he will be able to find the true value. In case if he finds, then we should say that he is really lucky. Then, okay, if we understand that every measurement has got some amount of error, then the measurement, how do we express? Definitely we know that in the measurement there is certain amount of imperfection. So, the imperfection is expressed in two ways. We say that the measurement is accurate, otherwise we say the measurement is precise. So, in physical measurement, what do we actually mean by the term that it is accurate and it is precise? So, accuracy or accurate, it means definitely a physical quantity which you are measuring will have some true value. Now, accurate, it tells the observed value, how close it actually is to the true value. I have chosen an example. I will explain with the help of an example, we will get to the point. Now, we need to simply know that accuracy, it means it tells us that how close an observed value or say measured value is to the true value of the physical quantity. When you say it is accurate, that means the measured value is very close to the true value. Next, if we say the value is precise, what do we actually mean? Whenever we make a measurement, we measure 3 times, 4 times, 5 times. In our lab, we ask students to measure minimum 5 times. So, when we make more number of measurements for a physical quantity, the errors will go on decreasing, or we should say that the measurement will be more closer to the true value. This is the reason why we ask the student to measure a particular physical quantity more number of times. So, therefore, whenever we make a particular measurement for say 3 to 5 times, then it tells how close is the different observed values when we compare to one another. If the values measured are very close, so 3 times you measured, all the measurements are very close to one another, we say that the observed value is precise. So, this is what we mean by the meaning of the term precision. Let us try to understand using this example. What it is said is that we have a rod and its length is measured, and the true value, I said actual length of the rod, the true value of this physical quantity, what you call length, is 2.250 centimeter. Now, we ask student A, B, C, 3 students to measure the length of the rod. Student A attempts 3 times, he measures the length of the rod 3 times. The first measurement he makes 2.25 centimeter, second time he makes 2.27, and the third time he makes 2.26 centimeter, and the average of all these 3 values he get 2.26. We can note that this is the value actually he has calculated the length of the rod, but the true value is 2.250 centimeter. B does the same thing. He measures the same rod, the length to be 2.252, 2.250 and 2.251, and the length of the rod he calculated is actually 2.251 centimeter. And student C does the same process, and he calculates the length of the rod. In the first measurement he got 2.250, second 2.250 and 2.251 centimeter, and the average he calculated, he gets 2.250 centimeter. Now, we want to make out the meaning of the word accurate, or say accuracy, and precise or precision. Now, when we look at the student A, here see please, 2.250 is the actual value. However, he has calculated it as 2.25, and the least count of the instrument is 0.01, and this is 2.27, 2.26. Now, the value he calculated is 2.26, and if I compare, this value is not closer, and therefore we say this this value is not accurate, because the calculated value and the actual value are not close by when we compare to the other values. So therefore this is not accurate. At the same time, if I see all the three measurements, one is 2.25, another one is 2.27, 0.02 difference, and 2.26, 0.01 difference. Therefore, the measured values are also, when compared to one another, are not very close. Therefore, it is also not precise, because between different values the difference is more, and therefore we say that this value is neither precise nor accurate. Let us check for B. When I see B, the value calculated by him is 2.251, the actual value is 2.250. So therefore, this is not exactly closer to 2.250. So therefore, I would not call the value as accurate, because the true value is different than the value he has calculated. So therefore, definitely this B has a precise value. Now you may ask, sir, 2.25 and 2.27, here it is 2.252 and 0.250. So the difference is 0.002, whereas here the difference is 0.02. So this is 10 times larger in comparison to the value calculated by B. So therefore this is precise. B is precise but not accurate. If I see the third one, student see what he has done. See please, the value calculated is 2.250 and the true value is 2.250. So therefore the observed value and the true value is matching. So comparatively this value is more accurate. This value is more accurate because true value and observed value are closer to one another in the sense they are exactly equal. Then to check whether it is precise or not, I am going to compare the values measured by student C. So the different measurements when I see here it is 2.250, 2.250. Therefore, these two values are really very precise. And if I compare the third one, all the three values are revolving around very close to one another. So therefore, this is very precise. So thus C, the data the observation he has made is both precise as well as accurate. So this is the actual meaning of the terms accuracy and precision in measurement. So dear students, technically what do we actually mean by the term error? See, error is equal to true value minus measured value. So when you find true value minus measured value, this is nothing but the difference between the observed value and the true value is called an error. As I told you that when we make measurement of any physical quantities, the measurement is limited by the instrument as well as the skill of the person who is measuring. So therefore, the true value minus observed value will be error. Now what are the types of error if you ask? broadly we classify the errors as systematic error and random error. What are systematic errors? See, systematic errors, this type of errors will have either positive sign or negative sign. That means because of the systematic setup of experiment or due to the zero error of the device, say, so that means these types of errors creep in due to fault in the system of measuring the physical quantity, and therefore we call it as systematic error. So whenever there is an error in the system, then the error that will crop up will follow a particular sign. The error will be in positive values, or otherwise the error will be in only negative values, not positive as well as negative. Then definitely this systematic error will have some causes. Because of some cause, these sorts of error come in, and the errors will follow some rule. As a result, the error will continue to be positive throughout. If that is the case, then if causes of the errors are known, and if we remove the causes, that means the errors can be eliminated. The errors may be due to zero error of your instrument, or otherwise imperfection in setting up the experiment or in experimental technique, or otherwise when you do experiment there may be change in the weather conditions. So like temperature, pressure, these weather conditions may also let you the error in the observed value. Next, if you look at the random error, what it says, random error, the causes are not known. When causes are not known, then the errors can be positive as well as negative. If you do say 5 measurements, 2 measurements can have positive error and 3 measurements can have negative error. So positive as well as negative errors are possible. The magnitude will also be irregular. When you observe the measured value, the magnitudes will randomly change. These errors do not follow any cause. Therefore, we will fail to find the cause and we will never be able to block or to stop the causes, and therefore we cannot so easily remove these random errors. And therefore, to minimize the error, what we can do, because the causes cannot be known in irregular or say random error, in that case we can ask our students to do large number of observation. This is the reason I told you that we ask students to take 5 to 6 times readings for a particular physical quantity. It is to minimize the random error present in it. Let us move on to the next topic. Now, you see, if a student does measure a physical quantity and I say that A1, A2, A3 and say up to AN are the observed values, right? And the physical quantity that the student is measuring will have a true value also. Now, we want to find the mean of all the observed values, or say average of all the observed values, and that we are going to call it as mean value of the physical quantity. And as such, see observed values A1 plus A2 plus A3 plus dot 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 plus AN over N. This is going to give me the mean value or average value of the observed physical quantity. And in short, we can write in the condensed form like this: average of measured value is equal to summation of I is equal to 1 to N AI, all measurements divided by N. Second, what we do with these observed values, we can find what is the absolute error in individual observation or individual measurement, and see the absolute error present in the first measurement is equal to now average value. When we find the average value, this is regarded as the true value of that physical quantity, because the true value of physical quantity will not be known to anybody. The true value has also to be measured, and I told you that when we make a large number of observations and if you find the mean of those measurements, then that value is regarded as the true value. So, for us A bar or the average value is the true value of that particular physical quantity which is being measured. So, therefore, this is true value. So, true value minus measured value. So, this is the error present in the first measurement and this is the delta A2 error present in the second measurement, error present in the third measurement, as such the error present in the nth measurement, and we call individual errors as the absolute errors in individual observation or measurements. Then if you look at next term is called mean absolute error. Now, what is a mean absolute error? We found that absolute error in each of the measurement or observation. Now, if we find the mean of these things, be mindful that when I find delta A1, delta A2, delta A3, some delta A, that is the absolute errors, can be positive, some can be negative. Now, when I try to find mean of all these absolute errors, in that case I take only the magnitude, only the positive quantity of all absolute errors, and therefore, see, sum of all absolute errors over number of absolute errors if we do, then we are going to get mean absolute error. So, it is easy to calculate. Next concept if we look at, we also call in the measurement space as relative error. When we say relative error, what it actually is? It is the ratio of the average absolute error or say mean absolute error to the true value. A I wrote, so it is a true value, I shall write this one like this. So, relative error is the ratio of mean absolute error to the true value. We should take note of that this relative error will not have any unit. The next concept if we look at, we have percentage error, and here the percentage error is nothing but we find the relative error and we multiply into 100 and we express it in terms of percent, and this is how we calculate percentage error. Dear students, many a times problems are asked by giving certain observed values to calculate what is the mean absolute error, relative error and percentage error. So, we must be mindful of all these formulas. Let us move on to the next concept. So, the next concept, dear students, what do we do actually with the measured values? Many a times we use these values in formula, and the formula can be like this. For example, say z is equal to x plus y. X is one observed value, y is another observed value. I can find the sum of these observed values to get a result called z. So, therefore, observed values can be used in algebraic expressions. Algebraic expressions, we mean we can add, we can subtract, we can multiply, we can divide, or at many a times we will find the powers of the physical quantity or sometimes combination of all these. So, thus when we combine all these observed values, we know that each observed value has got error. So, when we do operations on these observed values, we know the errors will also progress. So, we need to be mindful of the maximum error present in doing these calculations. So, let us find first the errors present, that is the maximum error present in addition. While adding two physical quantities, what could be the maximum error possible? Let me say x is one observed value, or say x is a true value, y is another true value. So, this is a true value, I said, this is a true value, similarly this is a true value, and if I find the sum of the two, x plus y, true value and true value will give me true value. So, this is also a true value. But when I asked a student to measure this physical quantity, he will have come out with x plus or minus delta x. So, this is a measured value. This is a measured value or say observed value. Similarly, the next physical quantity when he measured, he could have got the value with some errors, say this is the case. So, this is a measured value. Now, when he is trying to use these measured values in the formula, in that case he is going to add the two. So, x plus or minus delta x plus y plus or minus delta y, and he is going to get the result. Of course, in the result he is going to have the error also. So, for me this delta x and delta y is the part of the error in the measurement. Now, in this case when I open the bracket, I am going to get x plus or minus delta x plus y plus or minus delta y. If I rewrite this, I am going to get x plus y plus or minus delta x plus or minus delta y, and this is going to be z plus or minus delta x. When I compare this expression with this, I see that this z is equal to x plus y. So, here z is equal to x plus y goes off. So, I am left with plus or minus delta z is equal to plus or minus delta x plus or minus delta y. In this case, what I am bothered about? I am bothered about the maximum possible error present in it. So, here 4 possible errors are there. What are they? 1. The combination is delta x plus delta y. The second value could be minus delta x plus delta y. The third value can be minus delta x minus delta y, and the fourth value can be plus delta x minus delta y. So, these are the 4 possible combination of the errors when I find the sum of the two physical quantities. Now, from all these 4 errors, what I am interested in is I am interested in finding the maximum possible error, and the maximum possible error is this one. So, I must be mindful. So, thus the maximum error possible in a sum is equal to the sum of the errors present in individual measurements. So, this thing we need to keep in mind. This is the maximum possible error. So, this is error in addition. Now, we can look for the error in subtraction. So, when I see error in subtraction, in that case, let us put this way: error in subtraction. And if I see again, let x be the true value, y be the true value of the two physical quantities, and I want to subtract. In that case, let me put this way: x minus y. I want to subtract y from x. So, in that case, when I subtract y from x, I am going to get the result z. So, z is the true value for me now. In that case, when I asked the student to measure the physical quantity, he observed the physical quantity as x plus or minus delta x, which is the measured value. As such, again he measured the another physical quantity y. He came out with the measured value as y plus delta y, which is again observed. Now, he wants to subtract y from x. So, therefore, he wants to subtract. I am going to open the bracket. When I open, this will be minus, plus will become minus, and minus will become plus. So, I am going to write like this. As such, now this is going to be x minus y, and I know that z is equal to x minus y. So, z and x minus y will go off. So, I am left with like this. This is minus, this is plus. Again, if I look at, I will be left with 4 alternate possible combinations, and of all those 4 combinations, these are the things. Now, what I want to see what is the maximum possible error that will be progressing while doing the difference of the two measured physical quantities. In that case, again the maximum possible error is this. Thus, while we do subtraction, we will find that the maximum possible error is equal to the maximum possible error that will be present while doing addition of two physical quantities. Now, next let us check the progress of errors when we do multiply two physical quantities. So, the errors in product, when we try to check the errors in product or while finding the product of two physical quantities, let us assume the same thing. Let x be the true value of one particular physical quantity, let y be the true value of another physical quantity. We want to find the product of x times y. I am going to get the result, again this is going to be the true value. But when I asked a student to measure this particular physical quantity, he came out with the measurement as x plus or minus delta x. So, this is an observed value or measured value. Similarly, when he measured the second physical quantity, he came out with y plus delta y. Again, this is an observed value. When we ask to calculate the product of the two, in that case he tries to find the product between the two. So, like this times y plus or minus delta y, which is equal to, he is going to get the answer, and he knows that since it has errors, so therefore the product will also have error. Now, when we try to open the bracket, when we find the product, so this will be x into y plus or minus x times delta y plus or minus y times delta x plus or minus delta y, delta x times delta y, and this is equal to z plus or minus delta z. We know z is equal to x into y. So, here I have z, I can remove. As such, I am left with plus or minus delta z is equal to, I will write this term first. So, plus minus y delta x. Second, I am going to write this term. So, plus minus x delta y, and finally, this is delta x times delta y. Now, delta x itself is small, delta y is also small. When I find the product between two very small quantities, then this becomes negligible. That means, even if I leave out these two values or the product of delta x delta y, it is not going to make much difference in my error. So, neglecting delta x times delta y, I am left with delta z plus or minus y delta x plus or minus x delta y. I am going to divide both sides by delta z, z, or say z is equal to x into y. So, this is going to be plus or minus y delta x divided by z I divided here. So, z I will be dividing here, I know z is equal to x y plus or minus x times delta y x into y. Now, this y and y goes off, x and x goes off, otherwise I have delta z by z is equal to plus or minus delta x over x plus or minus delta y over y. Rather, I would say that this is nothing but the fractional error. This is the fractional error in the product. This is the fractional error in the product. And again, this is the fractional error. This is the fractional error in x, and this is the fractional error in y. Now, I am interested in finding out what is the maximum possible error present in it. So, therefore, again I am left with 4 combinations. What are those combinations? If I look for all those 4 combinations separately, I am going to have delta x over x plus delta y over y, and the other one is delta x over x minus delta y over y, minus delta x over x minus delta y over y and delta minus delta x over x plus delta y over y. So, these are the 4 combinations. A physics student always bothers about the maximum possible error. He will be very cautious enough. In that case, the relative error, maximum relative error present in a product is always equal to the sum of the relative errors of individual measurement. X is an individual measurement, y is an individual measurement. So, this is the relative error of x, relative error of y. So, sum of the relative errors of individual measurement is the maximum error present in finding a product. So, dear students, let us put off this session now. In the next session, we will continue with these topics, and almost we are getting closer to the end of this chapter. Hopefully, in the next class, we will finish up this chapter. Thank you very much.